teacher Jason and I am your math teacher. For today's lesson, we are going to learn highest common factor. So what are you waiting for? Let's start. Good day, students. Our lesson for today is all about finding the highest common factor using the division algorithm method. By the end of this lesson, our goal is to find the highest common factor or the HCF of the given numbers using the division algorithm method. Before we proceed to our new lesson for today, let's have a review. Our past lesson was all about finding the highest common factor by using prime factorization method. In this lesson, we'll learn that in finding the HCF or the highest common factor, we can use prime factors of the given numbers by prime factorization. Now let's have 12 and 16. We are going to find the highest common factor or the HCF of 12 and 16 using prime factorization method. First, find the prime factors of 12 and 16. And the prime factors of 12 are 2 multiplied to 2 multiplied to 3. And 16 are 2 multiplied to 2 multiplied to 2 and multiplied to 2. Then, find the common or the same prime factors of the given numbers. And we have 2 and 2. Then, after this, we are going to find the product and we will get the highest common factor, which is 2 multiplied to 2 is equals to 4. Now let's proceed to our new lesson and let us find the highest common factor by using the division algorithm method. What is division algorithm? Division algorithm is a method of factoring which allows you to factor two or more numbers at once. Let's have our first example. Finding the highest common factor by division algorithm. In our first example, we are going to find the highest common factor of 12 and 16. For this, we are going to write the numbers in the ladder, then find the common prime factor to use as our divisor. So we have 12 and 16. 12 and 16 are divisible by what? By 2. So let's divide them by 2. 12 divided by 2 is equals to 6. And 16 divided by 2 is equals to 8. Then we are going to continue dividing 6 and 8 since both of them can be divided by the common prime factor. 6 and 8 are divisible by 2. So 6 divided by 2 is equals to 3. And 8 divided by 2 is equals to 4. Now, let's stop dividing 3 and 4 since there is no common factor other than 1. Then, we can use the divisors to find the highest common factor by multiplying them. Thus, the highest common factor of 12 and 16 is 2 multiplied to 2 is equals to 4. Let's have our next example. Find the highest common factor of 12, 16, and 20. Again, Let's write the given numbers in the ladder. We have 12, 16, and 20. Then find the common prime factor to use as our divisor. 12, 16, and 20 are divisible by 2. Yes or no? Yes. So, 12 divided by 2 is equals to 6. 16 divided by 2 is equals to 8. And 20 divided by 2 is equals to 10. Because 6, 8, and 10 can still be divided into the common prime factor, which is 2, so we are going to continue dividing them. 6 divided by 2 is equals to 3. 8 divided by 2 is equals to 4. And 10 divided by 2 is equals to 5. Now, in 3, 4, and 5, is there a common factor to use to divide them? No. There is no common factor to divide 3, 4, and 5 other than 1. So we can stop dividing them. Then, what we are going to do is to multiply all the divisors to find the highest common factor of 12, 16, and 20. Therefore, the highest common factor of 12, 16, and 20 is 2 multiplied to 2 is equals to 4. Now let's have our last example before you are going to answer your textbook. Find the highest common factor of 40 and 48. Again, first thing to do is write the given numbers in the ladder. So we have 40 and 48. Then, find the common prime factor to use as our divisor. 40 and 48 are divisible by 2. Yes or no? Yes. So, 40 divided by 2 is equals to, very good, is equals to 20. How about 48? 48 divided by 2 is equals to, very good, is equals to 24. Now let's continue dividing them using their common prime factor. What is their common prime factor? Yes, very good. It's 2. So 20 divided by 2 is equals to 10. And 24 divided by 2 is equals to 12. Now 10 and 20 can still be divided into their common prime factor. Yes or no? Yes or no? Yes. So 10 and 12 can still be divided into their common prime factor, which is 2. So 10 divided by 2 is equals to 5. And 12 divided by 2 is equals to 6. Now, in 5 and 6, is there any common factor other than 1 to use in dividing them? No, we don't have, so we are going to stop dividing them because there is no common factor other than 1 in 5 and 6. So we are going to multiply all the divisors to find the highest common factor. Therefore, the highest common factor of 40 and 48 is 2 multiplied to 2 multiplied to 2 is equals to 8. Got it? Very good, students. Students, it's your turn to answer your textbook. Please answer pages 78 and 79. We are done with our lesson for today. And in this lesson, we learned how to find the highest common factor or the HCF of the given numbers using the division algorithm method.
Thank you for watching and see you again next time. Keep safe